Well, hey there, it's that coding guy here, breaking it down and making it accessible. Interfaces, super confusing, right? Well, stick with me and we will demystify them. In this video, I'm going to talk about overarching concepts, and I'll save the actual code for a future video. Trying to make things as short and punchy for you guys so that you can dig in, find the content that you need at any given time without having to sift through too much stuff in one video. So, interfaces, what are they? We'll start off with what they are. And then we'll talk a lot about why. Why? Interfaces are an abstract reference type. They're not a class. And we can't actually instantiate an instance of an interface. Well, how does that help us? Because, we've got classes that we can actually instantiate and use to store data and do things. What is the use of an interface? An interface is a contract. That's the way I like to think about them. And while they can have constant fields and values set up, their main use is to define method signatures. And these are weird. They're not normal methods that we would think about seeing on a class because they don't actually have any implementation in them. So let's review what exactly a method signature is, in case you're fuzzy on that. A method signature is a access modifier like private or public or default. It's a return type, right? Like whatever data type that method is going to return in the end. It's a name, and it's 0 or more parameters, right? It's the parameters that method can take when we invoke it. And then there's nothing, there's no curly braces and no logic in there in an interface. So what's the value of this? Well, it's a contract. It sets up the idea of what we want to happen, but not how it happens. And then a class comes along and implements this interface, which is a keyword, implements, and then it has to provide all of the implementation details for every method in the interface. Otherwise, it will not be a valid class, and the compiler is going to give us lots of problems, and our code isn't going to run until we fix it. So why? Why do we do all of this? Well, let's think about, I think understanding solutions is easiest when we come up across the problem first. So let's talk about what kind of problem, what kind of corner we could paint ourselves into for a minute. Let's imagine that we've got this text helper application, and this text helper, its main job is to actually interact with text files. And we're like adding lines to the text files, and we're reading lines from the text files. And this is probably part of some larger application. And we've got logic sprinkled around in that file over there for how to open a text file. And then we've got some logic over here somewhere else to validate the text file. And then we've got some stuff to write to the file and read from the file. And it's kind of all over the place. It's spread throughout a bunch of different files. And then one day we come in and we're like, uh-oh. Now my application has to deal with XML files too. I didn't plan for that. And I don't want to remove all the code that I've got for my text stuff, but now I need this XML stuff too. So what I could do is just in every place all of that text helper file stuff is, I could add in like XML file stuff to like read and write to an XML file because it's a little different than a text file. And now our code is even more messy. And then maybe, after a minute, we're like, oh man, we've got to support Excel files too. Oh boy. And as you can see, like as complexity grows and we have to do more things, like our code just became a hot spaghetti mess, right? So the idea is, if typically in Java, the idea is let's set up an interface first as a matter of practice, as a matter of best practice, just in case we need it in the future. We're going to start off with it. And that'll make our lives easier if we ever have to in the future. So what that might look like here is something like this, where our file helper is the interface, and it defines some of the main things that we have to do. And I was thinking about like the 4 main things that you would do with data and one of these files. You would create, you would read, update, or delete. So this, at the least, this file helper's probably got the method signatures for these 4 operations. And then these are implementation classes. So this implementation class is going to provide, it's going to implement this interface, and it's going to provide all of the code, all of the actual logic in those methods to do what it needs to do with a text file. And then the Excel helper is also going to implement this interface, and it's going to provide all the code necessary to do all of these things with an Excel file in particular, and so on with the XML helper. And in that way, all of that stuff is encapsulated in each of those implementation classes, but they are all file helpers. And so that is the value there. We draw up this contract of method signatures. Hey, these are all the things we need to do, not how. And then it's the implementation class's job to provide the actual how, that implementation of that contract in order to be valid file helpers. So we will check out some code in the very next video and see what this actually looks like in code with IntelliJ and all that good stuff, and we'll walk through how to get it done. So hopefully that demystifies the reasoning on interfaces and why. It's really future-proofing for us so that if anything needs to change in the future, no worries. We'll just create a new implementation class. As long as we've got that interface defined, it's a big organizational tool to encapsulate all of these different things in their own implementation classes. And it keeps things very loosely coupled. If something needs to change in how we're doing the Excel stuff in particular, we know exactly which class we're going to go update, and that code is isolated from the text helper and the XML helper. So each of those 3 pieces can change and flex independently of each other, and they won't have to affect each other. And that's loose coupling, and that is fantastic for our sanity, for updating code and maintaining code and testing code. It really helps out. So by and large, it's all about helping us in the future when we do these create these interfaces. And it is typically best practice to do these just in case you need them in the future. But of course, your mileage will vary on whatever team that you're on and however their processes work. So hope that helps. Cheers.